Welcome dear students to my channel Chemistry Knowledge. Now in this video I would like to continue from the previous part of periodic table where I had discussed about the atomic size and something about ionic size. Now in this video I'm going to cover two important topics, that is the metallic non-metallic character and the ionization potential. So before going into the topic, I would request to all my viewers to kindly subscribe my channel so that you get updated with all my videos related to chemistry knowledge. Now, metallic and non-metallic character. Okay, what is metallic character? The tendency of an element to donate electron. And what is non-metallic character? The tendency of an element to accept electron. The definition is very easy. Let me give you one more example. Everything will be clear to you. Let's see, I have sodium here with me with 1 electron in the outermost shell. Okay, configuration is 2, 8 and 1. Okay, and I will make chlorine out here with 7 electron in the outermost shell. So it is 2, 8 and 7. Okay, now if you look at sodium, if you look at this example which I am going to do here, now sodium has, this is sodium, I'll write it here. Now sodium has 1 electron in the outermost shell and this is chlorine which has got 7 electron in the outermost shell. Now you tell me students, this sodium and this chlorine both are unstable atoms. Why unstable? Because they do not have complete octet in their outermost shell. Okay, so this sodium and chlorine, they try to become stable. How they will become stable? Either by donating electron or by accepting electron. So if you donate electron, you become a metal. If you accept electron, you become a non-metal. How to understand which one is metal, non-metal? You just need to remember the configuration. See, sodium 281. Now you have 1 electron in the outermost shell. You tell me which one is easy, to accept 7 or to donate this one? Obvious answer, donate this one. That means sodium will donate 1 electron and it will become Na plus. Okay, what is sodium? Metal. Why? Because it donated electron. Come to chlorine. Chlorine has got 7 electron in the outermost shell. Okay, now which is easy for chlorine? Accept 1 or donate this 7. Then definitely you cannot donate 7, you will accept 1. Understood? What is chlorine? Non-metal. Why non-metal? Because it accepted 1 electron. Now let's see the configuration of Na plus. After removing this 1 electron of Na plus, the configuration of Na plus will be 2, 8. Okay, and chlorine, after accepting 1 electron, the new configuration will be 2, 8 and 8. So what are you observing, students? So when you accept electron or when you donate electron, you try to complete the octet. That means metallic and non-metallic character is related to the stability of elements. Got it? Let's move on. Now trend. Again we have come. First of all, I will talk about metallic character and I'll come to non-metallic character. But while explaining metallic character, non-metallic character will be understood at the same time. Now the metallic character decreases as you move from left to right, and the metallic character increases as you move from top to bottom. See, one thing you always remember, if this side it decreases, then this side it increases, and if this side it increases, then this side it decreases. So this is a key word or a key technique. Now see, I have shown you this periodic table here. Now if you look at elements, I have already said if you move from left to right, what happens to metallic character? Decreases. That means lithium is a metal, fluorine is a non-metal. Am I clear? If you move from top to bottom, metallic character increases. That means potassium is a strong metal, lithium is a weak metal. In the same way, fluorine and chlorine, you move from top to bottom, what will happen? What will happen, do you think? See, when you move from left to right, you are moving from metals to non-metals. Okay, that means when you move from left to right, metallic character decreases. So what increases in turn? The non-metallic character increases. Okay, if left to right non-metallic character increases, what will happen top to bottom? The non-metallic character will decrease. Is that clear? So metallic and non-metallic character can be studied simultaneously in this way. Left to right metallic character increases, top to bottom decreases. So left to right non-metallic character increases, top to bottom decreases. They are just the opposite. It's very very simple. Now see, now the question arises, why left to right metallic character decreases and non-metallic character increases? See, to explain that together, I have taken this example. This example will make it clear to you. See, sodium has got 1 electron in the outermost shell, chlorine has got 7 electron in the outermost shell. Okay, now I have already said for sodium accepting 7 is almost impossible. So what this sodium will do? It will donate this 1 electron. Am I clear? That means what is sodium? Sodium is a metal. Come to chlorine. You have 7 electrons. Which one is easy to accept 1? Am I clear? That means what is chlorine? Chlorine is a non-metal. Am I clear to you? Why chlorine is a non-metal? Because chlorine can accept electron. And why sodium is a metal? Because sodium can donate electron. That means you are observing that elements on the left hand side of the table, they can donate electron. Okay, and the element on the right hand side of the table, they can accept electron. So this side there is non-metal, this side there is metal. What happens to the character? Metallic character decreases, non-metallic character increases. Very very simple. Now let's see top to bottom. Now if you come to top to bottom, then see, lithium has got 1 electron, sodium has got 1 electron, and this potassium, I have given you an example. The configuration is given here. Sodium the configuration, lithium, they all have 1 electron in the outermost shell. So all are equal metals. Answer is no. Why? See, look at the distance from the nucleus. See the distance. See the distance. In this case the distance is less, in this case the distance is maximum. Now you think, in which case the binding force will be more, this or this? Then your answer is very obvious, that in this case the nucleus can bind properly with this electron, and in this case the nucleus cannot bind properly with this electron. That means indirectly we are saying it is easy for us to donate this electron and it is difficult for us to donate this electron. So if it is difficult here and if it is easy here, which one is a strong metal, students? Potassium is stronger metal. Why? It can donate easily. And lithium is a weak metal. Why? It cannot donate easily. That's why when you move from top to bottom, the metallic character increases. Now let's come to non-metallic character, students. Non-metallic character already I have discussed with you from left to right. See, sodium has got 1, chlorine has got 7. Sodium will donate 1, it cannot accept 7. Chlorine will accept 1, it cannot donate 7. Am I clear? Then is chlorine is a non-metal, this is a metal. What happens when you move from left to right? It increases. Clear? Let's not waste time here. Okay, now this one is quite important. Let's give little bit focus in this part. Now fluorine has got 7 electron in the outermost shell. Chlorine also has got 7 electron in the outermost shell. Now fluorine can accept 1, chlorine also can accept 1. Okay, now the question arises, which can accept in a better way? Then the answer is, see, fluorine, the nucleus and the distance to the outermost orbit, this is small. But for chlorine, the distance of nucleus to the outermost shell, this is long. Now you tell me, if you have more distance and if you have a short distance, what happens to the attraction? Here the attraction will be less, here the attraction will be more. That means in this case there will be more attraction between the nucleus and electron. That means this fluorine can accept this electron easily or bind this incoming electron easily. And this chlorine, due to longer distance, cannot bind this incoming electron easily or in an efficient manner. That means chlorine is a weak non-metal. Why? Because it is not accepting or binding the incoming electron properly as compared to fluorine. Am I clear? That is why when you move from top to bottom, what happens to non-metallic character? It decreases. Okay, so I have made a simple like table or a graph kind of thing for you. See, move from left to right, metallic character decreases. So if from left to right the metallic character decreases, then top to bottom the metallic character has to increase. And the non-metallic character increases from left to right, that means top to bottom it has to decrease. So in this way, this is a simple keyword where you can remember the sequence of metallic and non-metallic character. And this is not only limited to this metallic and non-metallic. For ionization potential, for atomic size, the trend is same in the sense left to right increases, top to bottom decreases, left to right decreases, top to bottom increases. Okay, now let's move on to the next topic, that is the ionization potential. Now ionization potential is the amount of energy, just think in this way, this amount of energy to remove electron. From where you are going to remove electron? From a neutral isolated gaseous atom. Why gaseous atoms are? Because see, all the atoms are not in the same state. Some are solid, some are liquid, some are gases. To make it uniform, we will consider gases. Am I clear? Very simple definition. Now come to this. Look at lithium. It has got one electron in the outermost shell. Okay, we all know this lithium can donate this electron. But my one question to you is lithium a charitable person that it is going to donate this one electron? I don't think so. What makes this lithium to donate this one electron is you have to do something to this lithium so that it is bound to donate this electron. Am I clear? Because you are not going to give electron just like that. Why? Because this electron is also in contact with the nucleus. So what is that something you do to lithium to remove this electron? That something is nothing but energy. And what is this energy known as? This energy has a very beautiful name, students. This is known as the ionization potential. So once again, ionization potential is the energy which you supply here to remove this electron. Very, very simple. Come to boron. You have got 3 electrons. Here also you supply energy. What will happen to this electron? It is going to be removed. What is this energy known as? This is ionization potential. Clear? Now the next we have is the successive ionization potential. See, successive means one after another. Okay. Look at magnesium. It has got 2 electrons in the outermost shell. I will supply energy to magnesium. What will happen? Electron will be released. Now you may have a doubt that whether both electrons will go or it will be one by one. Then the word will suggest you successive. That means the electron has to go one by one. Am I clear? So in magnesium, when you supply energy, one electron will be liberated. And what is this energy known as? Ionization potential. I will label this as ionization potential number 1. For the first time I am supplying. Now after one electron gets liberated, then we move on to this figure, Mg plus. Now here also you supply energy. What will happen? This electron is released. What is this energy? This is ionization potential number 2. Am I clear? So ionization potential number 1 and ionization potential number 2, these two energy is supplied one after another. That is why we call them as the successive ionization potential. Clear? Let's move on. Now the main topic that we will discuss is the trend of ionization potential. This is a mistake out there, students, please ignore. Ionization potential is also known as ionization enthalpy or ionization energy. Okay, not EA. It's a mistake here. Now ionization potential increases from left to right. Okay, and ionization potential has to decrease from top to bottom if it increases from left to right. Now the reason, the keyword I have given here is increase in nuclear charge and increase in number of cell. So when you move from left to right, there is increase in nuclear charge, and when you move from top to bottom, there is increase in number of cell. Okay, so these are the factors which makes the ionization potential to increase and decrease. It can be better understood with this example, students. Please pay attention here. Okay, 3 set of elements I have chosen here, that is sodium, silicon and chlorine. Okay, now sodium has got 1 electron in the outermost shell, silicon has got 4 and chlorine has got 7. Now we are talking about a situation where all the elements, or from all the elements we are going to remove one electron. Okay, now in which case it is difficult to remove and in which case it is easy to remove, we have to analyze that first. Nucleus is there in all the elements, that means nucleus will hold all the elements or all the electrons like this. Got it? Now if you look at sodium and chlorine size, that is when you move from left to right, what happens to the size? We have already learned. Yes, students, very good. The size will decrease. If the size decreases, that means this nucleus can bind this electron in a proper way or a better manner. And if the size here in case of sodium is big, then this nucleus cannot bind the electron properly. Got it? I hope you have got the logic. That means if electrons are not binded properly here in this case, that means it can be removed easily. And here in this case, if the electrons are binded strongly, that means it is difficult for it to remove. So where you have to supply more energy? Yes, you have to supply more energy in chlorine and you have to supply less energy in sodium. So which one has got more ionization potential? It's very easy, that chlorine has got more ionization potential and sodium has got less ionization potential. Why? Because in chlorine you have to supply more energy and in sodium you have to supply less energy to remove the outermost electron. Am I clear to all of you? I hope I could make it clear to all of you. Now top to bottom, whenever you come to top to bottom concept, you should always think in terms of number of cells. That is going to give you all the answers. See, lithium has got 2 cells, K and L cell. Sodium has got 3 cells, K, L, M, and potassium has got K, L, M and N cell. Done. That means if you come to the distance, the farthest, and this is the nearest. Now you tell me, out of these 2 cases, which one has stronger binding energy, or in which case the nucleus can bind electron properly? Think. Answer is lithium. Why? Because it is very close from the nucleus. But in case of potassium, it is very far away. That means this electron is not binded properly by the nucleus. What does that mean to me? It means that this electron I can remove easily, but this electron I cannot remove easily. So in which case I will supply more energy? I will supply more energy in case of lithium and I will supply less energy in case of potassium. So what is energy? Energy is nothing but ionization potential. So what happens when you move from top to bottom? Ionization potential or the energy, it decreases. Am I clear, students? So in this way you can understand this concept in a very simple way. Okay, now I have brought some board questions for you, my dear students. Okay, now I think you all can take a screenshot of this and you all can try at home, and if there is any doubt you can comment me, okay, in my video. I will try to come up with the solution afterwards. But before ending my video, I would like to solve at least one question for you to make the concept clear. Okay, so let me take this example: beryllium, carbon, nitrogen, boron and lithium. Let me solve this example for you all. What we have to do is we have to make the increasing metallic character. Okay, now when we get this kind of question, first of all, then what will I do is I will arrange them according to the sequence, that means according to periodic table. Now if you remember periodic table, these elements are given where, from left to right, okay, but they are not arranged in sequence. So my first duty is to arrange them. So the first element that comes will be lithium. Okay, that means one thing is very important, you should know the sequence or the atomic number of the elements. After lithium comes beryllium, after beryllium comes boron, okay, after boron comes carbon, then after carbon comes nitrogen. So my first task is completed. You have to arrange them: lithium, beryllium, boron, carbon, nitrogen. Okay, now you have to think what happens when you move from left to right to metallic character. Think once again. Left to right you are moving, what happens to metallic character? Metallic character decreases. Sure? Okay, what is the question giving you? Increasing order. So is this the correct order? No, my correct order will be just the opposite. See, that means it will be nitrogen, it will be carbon, it will be boron, it will be beryllium and it will be lithium. Am I clear? I will give an arrow above them. Okay, there is no space, but this arrow should be above them, and just above that arrow I will copy this word. That means I will write increasing metallic character. Am I clear? Once again I am repeating. First of all, I will arrange them according to the periodic table, and I will think left to right metallic character decreases. Question is saying increasing, I will write in the opposite way. If the question was decreasing, then I will be copying the same thing. But since the question is just the opposite, increasing, what will I do is I'll copy the opposite way like this. I'll draw one arrow. Above the arrow, I will copy this. That means increasing metallic character. So this is the basic technique, students, how you are going to solve. In the same way, I request all to solve this, the second and the third question, and comment me in my video. Okay. Thank you, dear students, for watching my channel. If you like this video, please do subscribe my channel so that you get updated with all my latest videos, and do not forget to share and comment. Thank you, dear students.